So again, I want to say good evening to everybody and Happy New Year as we begin another year of webinars here from the National Weather Service in Boston. I'm Joe Deli Carpini, the Science and Operations Officer, and I'm going to take you through a review of our December 23rd and 24th storm. So we'll get right to it. And again, just go ahead and throw your questions in and I will answer them at the end. So this was we've been stuck in this pattern of kind of warm storms. It seems like lately every low pressure system goes to our west across the Great Lakes, and this was no exception. Ends up bringing some kind of mild air, temperatures in the 40s, 50s, even 60s, along with a lot of rain. And this one just before Christmas deepened rapidly as it tracked through the eastern Great Lakes, produced damaging winds across much of our area with minor to moderate coastal flooding. And the interesting thing was it was actually on both of our coasts, the east coast and the south coast, which is a pretty rare event. And behind the storm, and you actually can see a little bit here on the weather map, there were blizzard conditions across the northern plains as this storm was bringing rain and mild air to us. And eventually this Arctic air pushed into the region as the storm departed into Canada and produced what was a pretty rare band of ocean effect snow that affected Cape Cod and the islands, especially Martha's Vineyard. I can tell you in the 25 plus years I've been at this office, this was the first time I've seen a single band this intense down on the islands. Normally they're much weaker and only produce a few inches of accumulation. So we'll talk about all of this. There were really three parts to the storm: the high winds, the coastal flooding, and then the ocean effect snow. So we'll start in the first part. We're going to talk about the kind of the large scale pattern that was in place for the storm and then get into a little bit more of the wind damage threat. So let's start with that. And if you've seen some of our weather briefings, you've probably seen this table before. This is something we use kind of looking out in time, and the web address there is below if you want to jot it down. This is what's called a situational awareness table, and it's from what's called the North American Ensemble Forecast System. That's just a fancy term for essentially taking the ensembles from the American GFS model and the Canadian model. So it's just covering North America, and it includes a variety of weather elements that are kind of compared to the model's climatology. So as you can see, there are a lot of bright colors that are showing up here on the 23rd and 24th of December. We're looking at things like height, which is the Z. So the lower heights means a stronger storm system. You've got temperature differences. U and V are essentially the wind components. So you have an east-west component and U. V is the north-south, and you can see those were maxed out. Wind speed, sea level pressure, and then the last three are moisture variables. So you can see there's a lot. You can see something is cooking here, and it doesn't really tell you necessarily what's going to happen, but it at least gives us a good signal that certainly a higher end event is possible. So it's just a clue to, it's telling you, hey, something's there. I need to look a little bit deeper into the details to kind of see what's going on. So again, this is our situational awareness table. So we always start kind of on the big picture and work our way down. Now, if you click on one of those columns, you can look at the various parameters. So this is looking at the sea level pressure. Remember, it was down near the min, and you can see why. You've got a very powerful low pressure system here over the Great Lakes. So remember, this is the average pressure from both of the ensemble systems. So an average of 984 millibars is very, very low. And you can see it's in the minimum for the climatological percentile. So this is something that's very, very unusual. So given it's a track to the west, a very strong system, you can anticipate we would have very strong southerly winds, potentially reaching damaging levels as well, as long as a lot of mild air coming into the region. So if we look into some of the ensemble data, and that's what we like to do a few days out, it helps iron out some of the uncertainty rather than going from model run to model run. There can be a lot of flip-flopping, as you probably know. So this is looking at the GFS ensemble at 850 millibars. It's about 5,000 feet. And you can see that there is a very strong signal here. These are essentially the departures from normal. So the more deeper shading of color you see, that's telling you there's a more anomalous or unusual strength to the wind field. And you can see it's certainly focused across New England. You're seeing departures. These are standard deviations. So the greater the standard deviation, the more kind of unusual it is. And you can see that both in the two forecasts we have here. Showing, again, very strong southerly flow into New England by Friday. Now, something else we can look at are analogs, and these are from St. Louis University. It's called the SIPS analogs, and you may be a little bit familiar with these as well. What they do is they take the latest GFS run or the NAM run at shorter time ranges, and they run analog. So they find, something that was similar in the model database in the past, and they can compare it to different events. And then from there, you can compute various probabilities of things like wind gusts or snowfall or rainfall. So it is the one caution is it assumes that GFS forecast is correct and will verify. So we know that's normally not the case 3 to 4 days out. But in this case, it's showing a pretty good signal. This is the probability of winds greater than 40 knots or about 46 miles per hour. And you can see, definitely the coastal areas have a decent probability, and they're low, but that's not unusual at 4 days out, but fairly high, 50% roughly across, southeast Massachusetts, Cape Cod. So that's really showing, 4 days out, there's a pretty decent probability you're going to have winds, at least of 45, 50 miles per hour. So again, another good thing to just kind of get you in the ballpark as to, what an upcoming storm may bring. Now, one of the things that we've talked about that we use at our office and throughout all of the Weather Service now is called the National Blend of Models. And it's just a kitchen sink of all the model guidance that's available, both from the United States, from the European Center, from the UK, from Canada, all the model data that's in there, all of the what's called model output statistical guidance. So essentially throwing everything in and coming up with a forecast. And it actually does very well in day-to-day weather. When you get into some of the extreme events, it tends to be a little bit underdone because everything is, remember, kind of averaged. It's a blend. But in this case, it can point out some, it can give you some signals a few days out. And here, you can see definitely the potential for some 45 to 50 knot winds. Again, that's, in excess of 50 miles per hour across much of the entire region, especially you can see over the water too in the blue and some of the higher terrain where you're seeing the strongest gusts occurring. So again, it's giving you a signal that, yeah, there's something there. And we need to kind of keep our eyes, focused on the system for some potentially damaging winds. And then if we look at the wind gusts, this is probability of greater than 48 knots. And you can see the higher probabilities are definitely over the water and again, focused in some of the higher terrain here, Worcester Hills, Northern Connecticut, certainly the Berkshires and Litchfield Hills. But this is, again, another really good tool for looking at potential for wind gusts very far out in time. And the question is always, why is it 48 knots and not 50? Well, that kind of aligns with our marine warnings for storm warnings. That's the threshold is 48 knots. So having this, available 3-4 days out, we can certainly be in touch with our marine partners. And for the storm, we talked to the Coast Guard, Steamship Authority, Mass DOT, and talked about the likely interruption of ferry services and dangerous conditions for those fishermen and other people being out at sea during this time. So when we looked at the low-level jet, we're going to take a look at one of the model. This is a model analysis, actually, kind of showing what happened. But you can see there were two really distinct surges of strong winds, and you may remember this too. The first was during the morning, where we had a southeast winds. As this loops, you'll see it come through again. Southeast winds of 70 to 80 knots. And again, this is up at about 5,000 feet. So not all of it is going to mix down, but about half to 2/3 of it, potentially can. And then there was another smaller surge here in the afternoon and evening as wind shifted to the south-southwest of 50 to 70 knots. We saw most of our damage, though, during the morning with that first surge of wind that you can see here again, all out of the southeast, and those pink and red colors are winds in excess of 60, 70 knots. So another thing in forecasting that's favorable for strong winds are what we call rise and fall couplets. So we're looking at the pressure patterns, pressure change over a 6-hour period as the storm kind of moved through. And it might be tough to make out kind of the map here, but Boston is right about there, Massachusetts. You can see we've got very strong pressure falls across Maine. This was at 1 p.m. on the 23rd, and that's as that low pressure system was tracking up into Canada. And behind it, there were very strong pressure rises across western Pennsylvania of about 15 millibars in about 6 hours. That's pretty impressive. So it's the difference between these large pressure falls would look like they're on the order of about 20 millibars in 6 hours to a very rapid change in rising of about 15 millibars that's favorable for strong winds. And you can see 6 hours later at 7 p.m., we've got the stronger pressure rises centered right over New England at that time. All right, so that was the wind part of the situation. Now the coastal flooding, and this was actually a pretty unusual situation. Again, it featured pretty significant flooding along both sections of the coastline. Normally, we're talking about just the East Coast or just the South Coast, but in this time, it actually was both, and pretty impressive on the South Coast. So we'll talk about that here in a second. Just as an overview, again, it was what we call minor to moderate flooding, and I'll show you what those definitions are in a minute for both coasts. And it's unusual because we had more of a southeast flow. Typically, our nor'easters, if the winds are out of the east or the northeast, or with the storms cutting across the Great Lakes, or the winds are out of the south. But in this case, it was southeast. So it really, if you think about the New England coastline, it was focusing the wind and the surge along both coasts, Rhode Island and Cape Cod and the islands in eastern Massachusetts. Now, the water levels on the south coast ended up being about the highest observed in 10 years. Providence ended up, as you can see here on the right, reached their moderate flood stage. That was the first time since October 29th of 2012. That was the end of the Snowtober storm, I believe. Oh, that was 2011, but it was the year after that. But really, this was the most widespread flood event we've had since the Patriots Day storm back in 2007. And we saw surges just over 3 feet. That was a combination of the strong winds that we talked about, 15 to 20-foot seas, and the surge channeling right up Narragansett Bay. So think about it as the water was coming in off the open ocean. It gets squeezed into those sections of Narragansett Bay, and of course it's going to accelerate a little bit too. So that's what we call the channeling up the bay to the Providence area. Okay, so here's our definitions. Minor flooding. This is just the nuisance type flooding. We see this quite a bit throughout the year, during astronomical high tides in particular. Really just is no more than 1 foot deep. You can see there's a good picture of that here on the right. It really affects the vulnerable shore roads. Most of the roads are really passable. You maybe have some deep puddles in spots. Once in a while, some of the more vulnerable roads are closed, but that's about it. It's really just more nuisance flooding. When we get into the moderate category, now we're talking about flooding that's about 1 to 3 feet deep. Not a good idea to drive through it. This was not a good idea here. You have more widespread flooding of shore roads. Basements of shore homes can flood. A lot of coastal roads, you'll see debris washing onto them from breaking waves. And this is the time when there's usually the numerous road closures that are needed, and as well as some damage of structures due to wave action, such as things like docks, house decks or porches that are up near the high tide line. So, minor, again, and really not a big deal, but it's the moderate events that really start to cause damage and impact on the coastal communities. So one of the things that we do take into account, and I'll go through this as we take a kind of a look up and down the coast at what happened, are wave heights. So of course there's the impact of the water level alone, but if you add the impact of wave action, then you're talking about things like erosion and damage to structures. So that can kind of really add the impact to what were already high water levels. So I just took a look at some of the offshore buoys here. This is off of Mass Bay in northeast Massachusetts, peaked at about 20 feet. The Boston buoy out in outside of Boston Harbor was 18 feet. And off of Cape Cod, just north of Provincetown, there was a peak of about 17 feet. So, pretty respectable. I would say our average nor'easter, the seas get to about 15 feet, maybe a little bit higher. Our really true stronger storms can get in excess of 25 feet. And you talk about storms like the blizzard of 78, you're talking about seas 30 to 35 feet or higher. So this was, about half of that, but still, pretty respectable for a coastal storm. And then as we work our way south inside of Cape Cod Bay, the seas peaked at about 7 feet. So still pretty significant. And Nantucket Sound, kind of the same thing. And then the buoy that's well southeast of Block Island and the open waters peaked at about 21 feet. So we know that, seas were easily 15 to 20 feet. Not surprisingly, there were probably waves on the order of easily 25 feet with this system as well. So I'll show you, why we add the wave heights to this. But let's start. We'll work our way up and down the coast. We'll start up in northeast Massachusetts. The Salisbury, Newburyport area really experienced some moderate flooding, as you can see here. Plum Island in particular has been very vulnerable to beach erosion. Salisbury Beach as well. You can see there's quite a bit of erosion there. So these areas are really prone to added impacts from wave action. And even getting down to Ipswich, there was quite a bit of flooding there as well, you can definitely see reaching the moderate levels here by the middle picture. That's pretty deep water. And even on the left near Crane Beach, pretty good flood at the water coming in at high tide. And for these areas, this is what we kind of use. We'll take a look. This is the observed stage from the Gloucester tide gauge, which is peaked at about 12.5 feet, which is in the minor category. But when we use what we call our forecast matrix, we take the storm tide on the left, we take the average wave height on the right, and we can come up with an impact level. So that's what we use. And in this case, we had a 12.5 foot tide, 15 foot seas offshore. That puts us in the moderate. maybe even the low end major. But I think in this case, the southeast wind really prevented more major impacts. If we had winds more out of the east or northeast with what's called a greater fetch or greater distance over the water to pile it up, we certainly could have reached some low-end major flooding in this case. But I think the southeast wind kind of just prevented that. Now, as we work our way down the coast, this is Winthrop and Revere and Salem. These areas also were categorized as moderate flooding. And we know from the Boston tide gauge was just under 14 feet, which is what we use. And combined with wave heights of close to 20 feet offshore, we're well in the moderate. So we were somewhere between 15 and 20 feet, but anywhere maybe, a widespread minor to some low-end moderate flooding. That's certainly the case here, along with some splashover, some debris on the coastal roadways. But even, Salem, that's pretty impressive flooding for this event. Getting down into downtown Boston, even there, we categorize this as a moderate flood. You can see, fairly deep water here, Long Wharf in particular. Areas near the Harbor Walk flooded fairly well. Morrissey Boulevard is a frequent flood area. East Boston as well. You can see a lot of these pictures. And if we look at some of the numbers, the Boston gauge, again, it peaked just at about 14 feet, which puts it just on the level of moderate flooding. And really for you folks around Boston, anytime it hits 14 or greater, that's a pretty significant flood. So 14 feet alone will get you to moderate. Within the harbor, the waves rarely get above 2 to even 3 feet. So most of the time, it's just still water elevation in and around the city. But reaching moderate levels, that's going to give you flooding of 1 to 3 feet deep across much of the harbor front, Long Wharf area as well. So again, the 14 feet, that kind of sets flags for us that this is going to be a pretty good event. So definitely in the moderate category for Boston. Now, working down the way, this is, Cohasset areas. Cohasset's on the Scituate, where we know these are frequent flood areas. You can see certainly in Cohasset, this was moderate flooding, pretty deep water there. Scituate always seems to get the worst of it. This was definitely a solid moderate flood for Scituate. I've got a bunch of pictures here. Even down at Duxbury, this was a pretty good flood as well for them, moderate flooding. You can see a vehicle stranded there. In the middle, and the Bluefish River Bridge closed because of flooding. So again, solid moderate flooding for the South Shore communities of Boston. If we look at the tide gauge from Scituate, you can see it peaked at about just under 13 feet, about 12.8 feet, which isn't itself is in the minor category. But again, we add those waves, those 15 to 20 foot waves offshore, and that's going to put you into the moderate flood category from a forecast standpoint. So we know that this was going to be a little bit more than just, kind of a minor flood based on the wave action. Now, even on Cape Cod, Provincetown had a pretty decent flood out of this. And we don't have a lot of experience with the flooding in Provincetown on a southeast wind. It's more, with the big nor'easters. But you can see pretty deep water, a couple of cars stranded there. That one car on the left on Commercial Street actually got stuck in the mud. Even some damage on Commercial Street and some of the restaurants that were there, flooding of homes on Bradford Street. So this was a pretty significant flood for Provincetown too. And you can see the gauge there topped out just on the kind of the cusp of the moderate flood. It was about 13.8 feet, just below 14. And, we estimated, waves about a little over 5 feet in that part of Cape Cod Bay, but that puts you right into the moderate threshold, essentially. So again, pretty solid moderate flood for Provincetown. Now, the interesting thing from this storm is we just had a new gauge installed in Edgartown over the fall, and we began issuing kind of forecasts behind the scenes for Edgartown Harbor, and then we're trying to develop flood stages and really improve our services for Martha's Vineyard, where we really haven't had a lot of data from before. But with the new gauge, it's really helping us a lot. So we're able to take the data from the gauge in Edgartown and kind of correlate it to other areas that flood on the island, in particular here Vineyard Haven. If you're familiar with the Five Corners area around and Water Street around the Steamship Authority dock, those are frequent flood areas and more significant events. And you can see very deep water here. Definitely a solid moderate flood. In Edgartown Harbor itself, also, around the Chappaquiddick Ferry, Dock Street, these areas were inundated with pretty deep water as well. So this was a solid moderate flood for Edgartown Harbor. And we're also looking on correlating this information for Oak Bluffs, another area. You can see on Oak Bluffs Harbor there on the left on Lake Avenue, Beach Road, which goes down toward Edgartown. It's ocean exposed to the sound there. A lot of debris washes onto the roadway. You can see, again, pretty deep water. Road closures were needed. So this was a solid moderate flood for Martha's Vineyard. And this is what we're working on. So we've got, right now we're using the data from the Nantucket gauge, which was just under 6.1 feet, but also using data from the Edgartown gauge, which peaked at about just under 5 feet from this event. So we're working on a forecast matrix for Edgartown and for the other parts of the island, and it worked out pretty well. Figured just around 5 feet. The wave heights offshore were, maybe just shy of 8 feet, 6 to 8 feet, but puts us into the moderate range, maybe high, a higher end minor event, lower end moderate. But we'll be running this through a few more events, if we get any more through the winter, and kind of tweak it a little bit. But right now it looks pretty promising for improving our forecast and warning services for Martha's Vineyard, which is an area we really haven't been able to provide a lot of specific information for in the past. So we're certainly happy about that. And then for Nantucket, of course, no stranger to flood events as well around the harbor. This was more of a minor to, marginal, I would say, moderate flood event. And I'll explain why in a minute, but you can see a lot of the water is fairly shallow. There were a few areas where it was a little bit deeper. There were some road closures required, especially around Easy Street around the harbor. But you can see here, again, it peaked just below the moderate stage, 6.1 feet. The wave height out in the harbor, outside of the harbor, was about 6 to 8 feet, but we think the wind direction from the southeast really gave the harbor itself more protection. So we just didn't have the water flowing in from the north or the northeast like we normally do during the winter storm. So the wind direction from the southeast seemed to have spared Nantucket some of the greater impacts, although there was quite a bit of beach erosion on the south and east facing shores of the island. Okay, so we want to go down to the south coast, and this is the kind of more interesting part. We saw flooding in areas that we haven't seen flooding from in a long time. This is North Kingstown, and that's fairly deep water over there in Wickford Junction area. And you can see the gauge at Quonset Point was right into the moderate stage, about 7.8 feet. And we actually found out this week there was quite a bit of flooding at Quonset on the airfield, at the edge of the runway. There was debris washing up on the edge of the runways. So this is certainly one area we're going to follow up on with the folks in North Kingstown and try and provide a little bit more in the way of impact statements for them. It's just a pretty rare event to see flooding on that part of the bay. And in Newport and Middletown, again, more of a minor, low-end, moderate flood event, but it's rare, for these south coastal events to get into the moderate level outside of maybe a tropical storm or hurricane. So this was a pretty rare event. Crested just shy of the moderate flood stage, but you can see quite a bit of flooding around through portions of Middletown and Newport from these photos here. So again, a solid minor, maybe borderline moderate flood event for some of the bay communities there. And if we look at our forecast matrices for these locations, you can see we were somewhere between the minor and the moderate. For the ocean-exposed beaches, we were probably more in the moderate range, maybe a little bit less because the 7.5 is a little bit generous. But for Newport Harbor, it seemed to work pretty well. About a 7.5-foot tide was solidly in the minor, with about 3-foot waves in that portion of the harbor. All right, so on to part 3, and this is, I think, the most interesting part of the whole storm. It really didn't so much catch us by surprise, but as you watch this satellite loop, and this is looking kind of a nighttime type loop, you'll see first one band of snow up here across central and northeast Massachusetts, and that actually gave us a little bit of a surprise. For those of you who are in that area, you remember you got several inches of fluffy snow from areas like Fitchburg over toward Lowell and Lawrence that evening. Going into Christmas Eve. So that was the night of the 23rd. And meanwhile, you can see a second band here forming along the south coast, all the way from Long Island Sound across Cape Cod. And that was the band that eventually brought heavier snow to Block Island and Martha's Vineyard. So definitely a little bit of a surprise on the northern extent. We were kind of anticipating this southern band based on the model data, which I'll show, but really an unusual event. And again, like I said, in my 25 years at the office, I've never seen a single band extend across Long Island Sound quite like that. Normally, it's when the Arctic air was departing. We get some southwest winds. We get some multiple bands here near the islands, and that's about a few fluffy inches, and that'll do it. But this was actually on the front end of the cold air coming in because winds stayed out of the west and southwest. All right, so let's take a look at this. First of all, here's our surprise, and our friend Greg Forrester, who's our co-op observer up in Fitchburg sent us some nice pictures, and you can see the radar loop there on the right. There's our little surprise band in north central and northeast Massachusetts. The interesting thing is, if we look at kind of where the airstream came from, we run this model called high split, and it allows us to kind of do a backward trajectory. So where's the air coming from? And you can certainly see it's coming from the northern portions of Minnesota. And if you remember in the first slide that I showed, temperatures here were in the teens. So this was some very, very cold air streaming down across the Great Lakes and eventually ending up across north central Massachusetts, where it worked kind of with a secondary front to produce this nice band of fluffy, fluffy snow. And you can see there a final, current temp of 4 degrees and an, overnight snowfall total of 5.5 inches. So not bad, not a bad little band of snow that moved across. Okay, so on to the ocean effect snow, and this is a look that Friday evening. You can see on radar the main band is extending across the northern part of the island and then to Cape Cod. Here's a webcam from, this is Five Corners in Vineyard Haven. You can see it's snowing pretty decently at that time. And some of the snowfall totals that we received are listed here. You can see on Cape Cod we had an inch or two. On the Vineyard, anywhere from about 2 or 3 inches in spots to as much as 7.5. But even observer in Chilmark reported a 9.5-inch total over a couple of days and about an inch on Nantucket. So it was a pretty persistent band on that part of the island that actually ended up giving them the jackpot. So let's take a look. This is the entire radar loop, kind of showing you the evolution of the whole system. And you can see it originally, will start, and I'll wait for it to start again. It initially will drop south. We'll see as it begins here. It aligns kind of from Long Island to Block Island to the Vineyard. You can see it then starts to go a little bit farther to the north up towards Buzzards Bay as the winds back slightly, and then backs to the west again later in the day, pushing the band southward. So I'll let this play through again. You can see the band looks a little bit fragmented. That's probably not really the case. It's because the radar beam was actually overshooting it a bit. This was a pretty shallow band, only about 2,000 to 3,000 feet deep. And at this point, the radar is shooting at about 2,000 to 3,000 feet. So it's probably catching more the top of the band as opposed to the actual band itself. And the other thing to keep in mind is it was a pretty cold night. So when you see these higher reflectivities, 20 dBz in the green, that's actually snowing pretty well when it's that cold. So a couple of things were going on there as far as the radar sampling. But you can see here, band shifts south across the island, lifts north during the day Saturday to Buzzards Bay, then shifts back southward again and brings a little bit more snow. So pretty impressive 24 hours there for folks on Martha's Vineyard. All right, so we'll take a look at the analysis, kind of why this happened. And if we look at the 850 millibar level, about 5,000 feet again, we have what's called cyclonic flow. Low pressure is up to our north, counterclockwise flow around it. It's called cyclonic flow. And you can see that there's definitely cold air pushing into the area off the Massachusetts coast around this low. You've got temperatures, these are in Celsius, colder than minus 20 Celsius moving in. So definitely have some cold air coming in. Also what we call little weak short waves. You can see these little weak kinks kind of around the broad low, and each of those kind of act to enhance the lift that's in place. So if we go lower, and again, we have to stay in the lowest 5,000 feet because this is a very shallow feature, as I mentioned. We see a similar pattern. This is about 2,500 feet up from the ground. And similar pattern here. Again, this is kind of our best pressure level to use for ocean effect because it's a lot more shallow than we see across the Great Lakes. And as long as the fetch or the wind direction remains favorable, the ocean effect snows will persist until this flow turns what we call anticyclonic, or we see ridging coming in. So once this low moves out, high pressure starts to move in, the flow kind of turns the other way. We get a ridge coming in, and that gives you subsidence and will eventually kind of squash the ocean effect snow bands. So if we look down near the surface now, this is what's called the boundary layer, or just kind of above the ground where we don't have the effects of friction. You can see a lot of convergent flow here over Long Island Sound. Not a lot, but you can see a little bit these streamlines kind of coming together on a small scale across this area here. So we know we have some wind convergence that's also very favorable to help these bands of snow form. So our friend Tom Niziel used to be the former meteorologist in charge at the Buffalo Forecast Office. You may know him from the Weather Channel as well. Sent us some nice information. He's the lake effect expert, or guru, as I like to call him. And you can notice on this satellite loop pretty clearly, you can see convergence from these parallel shorelines, both along Connecticut and along Long Island. And this is actually kind of similar to like Lake Erie from what he noted. And you can see the main band here as I draw my mouse over it, extending across the islands from Long Island Sound. So you can see you've got kind of a west-northwest wind across southern Connecticut. You've got more of maybe a just south of due west wind here on the north shore of the island, and that's giving you convergence right along this portion of Long Island Sound, the north shore of Long Island to Block Island over to Martha's Vineyard. And you can see that more here. You've got, again, as Tom noted, that you've got a concave shoreline, Long Island Sound, Raritan Bay. Those are perfect breeding grounds for these kind of sea or sound effect snow bands. And you can see the cloud bands certainly highlighted here where the heavier snow was falling. Actually, there's a good one south of Long Island as well, as you can see here, and another one that affected us off of Long Island Sound. So a pretty neat feature. And again, nothing like I've seen in many, many years at our office. Okay, so let's look at some of the model soundings. That'll kind of show us a little bit more of the details as to what was going on. And if you remember, you can always go back to our webinar on ocean effect snow or the lake effect snow event we did with our friends from the Buffalo Forecast Office in December. We talk about the model soundings quite a bit, but it's essentially convection like thunderstorms, but it's in the wintertime. So we look at kind of the same ingredients. And you can see here, this is the sounding for Hyannis. This was Saturday morning at 3 o'clock in the morning. So things to kind of point out is we've got an inversion, or the top of our what we call the mixing layer is at about 925 millibars. Again, it's about 2,500 feet, very, very shallow. But the difference in temperature from the water, which was about 43 degrees, up to the top of the inversion, was about 19 degrees Celsius. And you only need about 8 to 12 degrees Celsius to really initiate flurries and light snow showers. So we more than exceeded that. We've got some pretty good instability. You can see what we call lake-induced, is really ocean-induced CAPE or instability, is about 389 joules per kilogram. That's pretty healthy for ocean effect snow, and a normalized CAPE is 0.22, and kind of our threshold for that is about a 0.18. So we've exceeded both of those. And you can see within this layer, you've got a very pretty much unidirectional flow, or almost a perfect west-southwest flow. Very little directional change through this layer. Winds are averaging anywhere from about 20 knots to 30 knots. It's a little strong for the best bands. We usually look for 15 to 20 knots, but overall this is a pretty good setup for snow bands across the islands. Now, if we move forward in time, this is 1 p.m. Saturday. Now, remember, at this point, the bands had shifted north of the Vineyard and not kind of more over Buzzards Bay, but really little change overall. You can see the inversions moved up a little bit. It's around 900 millibars, a little bit higher, so maybe just over 3,000 feet at this point. So now you've got more of a convective layer to develop these snow bands in. The temperature difference is still about 19 degrees Celsius. The instability's gone up a little bit, I believe. Let me just go back. No, it's about the same, 377, and the normalized CAPE is about a 0.23, but still a well-aligned west-southwest flow through this layer. It's a little stronger maybe, and probably a little too strong for really bringing the best heavy snow, but overall this is not too shabby for our south coastal areas. So I'm going to look at just finish up with some of the model guidance. You see it did a really, really good job, our high-resolution models. This is the high-res Ensemble, the HREF, which we show all the time. You can see, so I did some snapshots here about 2 in the morning on Saturday to see what was going on. And you can see the radar images here. The band is kind of on the northern part of the Vineyard near Vineyard Haven. And you can see in the model, the band really is just a little bit farther south. So the band is actually north of what the HRF position was at that point, and this is about a 7-hour forecast. So not terrible. It's definitely showing the potential for some banding over the ocean. It's also got another band a little bit farther. I think this was the band that was supposed to be over the Vineyard along more like Woods Hole over to the south coast of Rhode Island. So a little bit off. Now, if we look at the different members of the HRF, remember it's 5 different members, we can see what each one was showing to come up kind of with that mean forecast. And again, you can see this has definitely her model has the band farther north across Cape Cod, really nothing on the Vineyard at that point. If we go to the National Severe Storms Lab version of the WRF, this one's farther south. So it's a little bit south of the islands, has the right idea, but it's probably got a little too much westerly flow. So it's shunting this band a little bit farther south when in fact, this portion is probably correct on eastern Long Island and Block Island, but it's probably got a little too much westerly flow. And you kind of see the orientation of these snow bands look more east-west than kind of southwest to northeast. The other model, the ARW wharf, is located here. This is just a touch south as well. It's scraping more of like Edgartown and even the northern part of Nantucket. Again, it's got the right idea with a single band there across Block Island, but maybe just a little bit too much westerly steering flow that's going to shift it a little bit farther south. And then the 3-kilometer NAM that we look at quite a bit. Again, same idea. It's got some sort of banding signature there, a little bit weaker, but also a little bit farther south. So that just tells us, any subtle change in some of those lower level winds are going to cause changes in the position of the band itself. But again, certainly tells you there's the potential for a good snow band from Long Island Sound across the islands through that early morning. Okay, so in summary for this part of the event, we had a rare single band of ocean effect snow forming with southwest flow and Arctic air. And as I mentioned, we normally see these events as the Arctic air is departing, not arriving, so certainly very unusual. We had that broad cyclonic flow, a lot of instability, and a well-aligned southwest flow, which produced our band development. Overall, the high-res models did a great job pinpointing the threat area, slightly off in their position. That's not unusual, even with lake effect snows, but certainly highlighted the potential and helped us with our forecasts and messaging. And using the forecast soundings, like the ones we showed for Hyannis, can certainly help pinpoint the location and intensity of the bands. So just think it could have been worse. If you remember, over Christmas weekend, our friends at the Buffalo Forecast Office received 43 inches of snow up to Christmas morning. That brought their seasonal total to just shy of 93 inches and just below 2 inches below their average for the entire winter. If you remember from the webinar we had with Dave Zaff, which featured the first extreme event, he was actually at the office for this, and their comments here tells the story. On Christmas Eve morning, blizzard-like conditions for the past 18 hours. Heavy snowfall occurred with snowfall rates of 1.6 to 2.5 inches per hour, and several of them were stranded at the office. They were actually stranded, I believe 5 of them, from Friday afternoon all the way up through Monday morning. So they spent Christmas stranded at the office, including our friend Dave. So we thank him for that extra service during the holidays. So with that, I will pause here and I will look through for some questions. So let me just take a look and open up our chat. So let's see what we've got here. I think quite a few things in here. Let's see. Oh, my friend Jonathan. Yes, serious whiteout in the return flow on the night of 12/23 while driving through Beckett through I-90. Yes, I remember sending you the pics. Thank you, Jonathan. And I know you got your snow, so you did all right there. And comment from Joe, the European model has an extreme forecast index, similar to the table I showed. That's correct. For the storm, it was already nearing 0.9 to 1.0, meaning extreme event. That's correct. So we do use that as well. I didn't show that here, but that's another table you can certainly use for good situational awareness. Let's see what else we've got from from Ron. The moderate flood surge in the Providence, was the hurricane barrier closed? Yes, it was. We had talked with the folks at the Providence Emergency Management Agency really as early as Monday from that week. We saw the astronomical high tides. We saw the potential for surge. So yeah, it was closed. It did prevent further flooding into Providence, which is a good thing. That's what it was designed for. So yeah, they were able to do that certainly in time, as well as the New Bedford hurricane barrier that was closed as well. And let's see, from Ron, your pressure dropped to 29 inches even. That's pretty good. Yeah, it was definitely a pretty low pressure storm for us too. From Katrina, let's see, the ocean effect snow in Middletown was clear over my house, but I could see that snow band just south of us. Very eerie and weird. Yeah, if the bands are in the distance, it almost looks like similar to thunderstorms. You've got a lot of, even at night, it looks a little bit eerie. You see the snow and the kind of the fuzziness to the clouds where the snow is falling. But 2 to 3 miles away, maybe nothing happening at all. So pretty interesting storm. All right. Well, that is all I see from questions. So we will pause here for 1 second.